What's going on, everybody? Welcome to another Zabbix video. This time I will talk about resource consumptions, more precisely CPU resource, how Zabbix agent1 is utilizing CPU, agent2, and Zabbix proxy. Like, we have three components, and we usually ask ourselves, is the agent2 consume more CPU resources, and what's the ratio for Zabbix proxy? Proxy in a way also is some sort of agent. It has data collection capabilities, and how big is the proxy? Is it the biggest component, and then maybe some other agents are just a little bit smaller? And in this video, I will share what I think is the most exciting and also very precise mechanism how to start to measure and let's say compare agent 1 with agent 2 and see what is the difference for the CPU utilization. Okay, let's start with the it's a laboratory which will utilize Zabbix, Raspberry Pi 4, and inside this Raspberry Pi 4 I have a running Zabbix proxy and also running agent 1 and running agent 2. And both agents are using absolutely same scenario. It's running the Linux monitoring in the active mode, and then another template which is measuring what is the temperature for the CPU. If we check the other host, it's containing absolutely the same thing, and I can run both agents at the same time. As far as in terms for the passive checks, we have to have a different port for the listening checks. Before we go forward, Raspberry Pi 4 is having 4 CPUs or 4 CPU cores, and let's set up the monitoring for each CPU core, because my workaround will really utilize this. There is an elegant mechanism to tell the systemd service to use a very specific CPU core solely for that particular service, and the journey should start we should enable the monitoring. Here what we need to do is select system.cpu utilization. This is the item key, and the type will be, there is interesting mechanism. Official templates are using this approach, asking how much the first CPU 0 is doing nothing, and it will report percentage, and if we inverse the logic, this can range between 0 and 100, we can add a pre-processing step. And tell let's return 100 minus that while doing idle value, and it will give a very precise number how much time that CPU is doing something else other than idle. So it's some sort of inverse mechanism, but very, very reliable. So CPU 0 over here, let's create data collection 6 seconds to make it a little bit entertaining, and I will clone these guys. Just give me a sec. The 1 and the 2. Of course, in real life we would create some sort of LLD rule to take care of this thing, but it's even faster just to manually create. Maybe let's use the active checks, mass update type active update. Okay, so every 6 seconds it will measure all 4 CPU cores, and I have 3 components agent 1, agent 2, and Zabbix proxy. And the way how it works, we can tell the operating system to reserve CPU core 1 and 2 and 3 for other means, and of course it needs to use at least one core, and it will be the core number 0. And to do so, like what we need to do is actually let's start with the htop, which is entertaining. Like htop, let's start with the tmux actually, and inside the tmux I will open the htop, and htop shows like it's using like right now all 4 0 1 2 3, and yeah, right now it's using all, and my goal is to reserve the first core, I mean the core with number 1, agent 2, and then the proxy. So this is one source, like source of the truth, how it's currently working, like it's using all the cores. If I would do, like, let's split the screen, and there is another source of truth, which is like watch and like cat proc and stat, like this, and it's also representing the CPU usage in terms of counter, like we have CPU 0 1 2 3, and this is like the user time, and if I'm not mistaken, and this is the system time. And if the number is increasing, it's using the resources, and this is like super precise source to understand if the something is like scratching the CPU and taking the resources. And so right now we see numbers like this pi is running for multiple minutes so far. I will like close this thing, and now like to reserve the CPU for like to allow other services to use that single CPU solely for this to run the service, we need to edit this file as command line, and inside this file, almost at the very end, you say like isolate ISOL and CPUs in plural equals isolate 1 2 3, and it means like all the remaining cores, which is CPU 0, it will remain for the operating system layer. If you do the install additional packages, maybe some antivirus is scanning the system, that will use the CPU 0. So saving the file and rebooting the server, sudo reboot, enter, and now it's like going down. So while it's booting up, maybe it's entertaining to explore how was the graph going so far. If we search for I did not create the graph, let's create it, graphs, and graph, like new CPU, this will be fixed, add, and I will add here like all 4 so far today at the moment, add, and if we see the result here, like new CPU, enter, and this is the like all 4 CPUs were like running and consuming some like resources, and now after the reboot, like CPU 0 will be solely reserved for the operating system layer. It should start to show up something, and we can see like the green line at CPU 0 is like now a little bit busy, and every 6 seconds it's collecting, and all the other lines are flat 0. Let's do that other exercise again, like if we log inside the server, if we check the state of the services, systemctl status Zabbix proxy, Zabbix agent, and Zabbix agent2, enter, like all the services like are running right now. If we would do the same exercise with the tmux and run htop, enter, we see like it's never using the core 1 2 3. It's like it's completely isolated from the system, and only the core 1 gets hot. And now like how do I tell those services to now not stick with the core 0 and to start to use other things? And it's easy, like sudo systemctl edit, and like let's start with the proxy, enter, and inside the service definition I tell with this special string which core to use. Click, and for the proxy it will be the core number 3. Save the file, and let's have for agent, enter. For agent it will be 1. Save the file, and for agent2 it will be core number 2 here. Save the file, and then like since I did modify those definitions, daemon reload, enter, systemctl reload daemon. What was the command? Reload the history grep reload, maybe this one, enter. Okay, and now that's it. Like if I restart the services, then it will start. One entertaining bit, so we are currently let's clear the screen and launch watch and N1 and print the output of proc and stat and enter, and we see like from the moment of the system boot, like the CPU1 and CPU2, CPU3 has completely done nothing. Like this column represents idle, like how much it's a lazy like doing some laziness, and the CPU 1, 2, 3 is doing the lazy like all the time. And so I will open another window in here, the tmux like this, and I will boot up by one, like sudo systemctl and restart Zabbix proxy. So it's already running right now, but it's using the proxy is using like the central kind of like what's allocated for the whole system. And after the restart, like the proxy kind of should it's instructed to use the CPU 3 and enter. And voila, we see like the CPU is 3 is really increasing. So it's getting very entertaining. From at least I find this very exciting. Like if you care to measure like how much each service is consuming CPU power, like this is so it's like the maximum source of truth from my point of view at least. Let's restart agent2. Click, and now like CPU for agent2 is starting to go, and restart agent1, and finally like all 3 are in charge. Okay, and now like a race starts like for like agent1 and agent2 is kind of like doing same things. It's running the same template, it's running same data collections, and we can see like the data is similar here, and we can also see in the graph. Here we see the core 0, and if we refresh, finally, like some other lines are coming up. CPU 1 for agent1, CPU 2 for agent2, and CPU 3 for Zabbix proxy. Let's filter out last 1 minute. 1 minute, enter. And now like here we see competition. One interesting experiment is to link a template which is exclusive for agent2, and one of that templates are systemd monitoring. So it's exclusive for agent2 only. It's practically like a separate module, and maybe like it consumes a little bit more juice, more CPU, and let's find out. If I link this template here to the agent2 systemd monitoring update, so far the amount of items 73, and in the 7.0 version, like the template will it will execute discoveries like very fast, like in the next 20 or 30 seconds. It will run this, what's behind here, click, and the systemd monitoring is this one and that one, and eventually it will create like new items. So far it's 73. It should increase very soon if we go back. Not yet. Okay, maybe I should try manually or be patient. Apply. Okay, let's try manually. Here, click, execute now, and apply. Yeah, it did execute previously, 199. So quite a difference right now. It's a different competition. Like agent2 must do something much more, but still the same tasks for the it's configured for agent1. So let's see the graphs. Like will the red line, will the CPU, this one, it's located for that agent2, will it go up because agent2 is like needs to do more tasks? Let's click apply, and the answer is yeah, the answer is maybe a little bit CPU. I don't see too maybe it's like still like the LLDs. I mean, the items were made on the central server, and since the proxy is in the middle, like there is 20 seconds for the proxy to understand all those extra 100 items. And I feel like if we wait enough, let's click apply, the data, like the red line, should start to go up. How about data collection? Let's see. Click, let's see over here, and latest data, and hosts and agent2 latest data, like does those new service states are coming. And we see like 45 seconds ago, like it did produce something regarding the systemd service. What other metrics, like here, this is the systemd state, fake clock hardware, Getty, like systemd service, network manager. So it's running right now. Yes, and let's see the graph again. Maybe like new, enter, and yeah, it looks like so my theory is a little bit like wrong, or CPU2 it's for agent2, and for the like when I applied the template, the increase here on the line, maybe it looks like a little bit increase. The minimum metric is 0.65, the maximum metric is 0.71, and that is the difference while linking that template on the thing. I know what's the difference is the template is passive checks. So passive checks, the systemd template out from the box, it's using passive checks, and CPU free is for the proxy. And here the time frame is somewhere like last 2 minutes, and we can see this CPU free gone up because the proxy is doing the asynchronous data collection in 7.0 and starting to fetch those data for the systemd. Maybe let's prolong this, let's make the video even longer to prove the point. I get interested myself. Let's do convert here to the active update, this one also to the active update, item prototypes, and So now, like, the proxy will need to do less, and agent2 will need to do more. Okay, update, and let's see if there is no discard unchanged. That's great. So now the template is completely converted to use active checks. Let's try to force the discovery rule again. Actually, for the active checks we cannot force so easy, but we can, yeah, my bad, like to force the discovery must be passive. Click and click. So I want to convert, like add 100 more active items. And now let's count to 5. 1, 2, 3, 4, 5. Execute this one again. Execute. And if we filter out items, currently we have active items 79. Maybe it did work already. And agent2, apply. Just a little bit more, and dependent items. I see. It's doing. There are not too many services running in the Raspberry Pi. That's it did increase just a little bit. What about the graph? If we explore the graph over here, like the proxy maybe should go down and agent2 should go up. And the red line, agent2, it looks like it is going. Okay, 2 minutes. And exploring the data, agent2, enter, latest data. When is the last time the service did checked in? Active state, what is the item configuration? It is the pendant item. Up here, active time. Okay, apply. And filtering out last seconds. Okay, it's not allowing. Yeah, it fluctuates. I would say I failed to really prove the point. Like I was hoping to see a drastic increase for agent2, but we see it's going up and down just by 0.1%. Yeah, but the idea of this is like we are isolating the systemd definition, and that's one way to, like, this is not for production, it's more for the learning purpose. If you are excited to understand how the service works underneath the hood, how much power it consumes, it may be very important, like if you want to run that computer with the battery bank or something, then we can understand like which service drains the battery the most. So that would be the thing. Okay, that is everything for this video. If you find it useful, give it a thumbs up, and thanks for watching.